You're going to need a sheet of paper and pencil so that you can work. We're going to work through 5 different examples. And this is the first one of the 5. There's lots of ways of teaching this, and depending on who you had last year could make a difference on how they taught you how to do it. But be honest, how many people like to work with fractions? I didn't think there'd be many. The great thing about algebra is if it's in fractions like this, you can get rid of them. If it's going to come back with a fraction, it won't come back until you're done. What would be the lowest common denominator between everything that's up there? What would it be? Lowest common denominator between everything that's up there. What would it be? It would be 6. I would say let's get rid of the fraction. And what I'm going to do is I'm going to put parentheses around everything that's up here. And I'm going to put a 6 out in front. Remember, the rule of multiplication, property of equality, says if I multiply one side of the equal sign by 6, I multiply the other side of the equal sign by 6. So I'm going to multiply every single piece by this 6. Basically, I'm going to distribute it through here. Well, when I distribute it through, and I'm going to write this step out, typically I would not. I'm taking 6 times 2/3 x plus 6 times 5/6 equals 6 times a negative 3x. Normally, I would just kind of skip that step. I've kind of shown it here by putting that 6 out in front. What happens to this 3 and 6? How many times does 3 go into 6? 2. What's 2 times 2? So this becomes 4x. What happens to these 6's? They'd cancel out, and it'd basically be 1 times 5, or 5. And the 6 times a negative 3 becomes a negative 18. What's not in my problem anymore? Fractions. So the nice thing about working with an algebraic equation that has fractions in it, if fractions are intimidating to you, you can get rid of them. You don't have to work with them. I would encourage you to get rid of them. Usually I like to move the variable to where the variable is biggest. If I did that in this particular problem, there'd be nothing left on the right-hand side. There'd be a 0. This is one of the few exceptions where I would say, I'm just going to take this one over to this side because there's nothing else with that x already. It's going to leave me 5 is equal to a negative 22x. Again, the reason I like to move it where it's the biggest is I don't end up with a negative in front of my variable, which a lot of people make mistakes on. What's my last step going to be? I'm going to divide by a negative 22. And x ends up being equal to a negative 5 over 22. Questions? Now, how many people were taught, just out of curiosity, how many people were taught to get rid of the fraction last year? Okay. Some people teach to work with them. Some people teach to get rid of them. I personally think it's easier to get rid of them, but whatever method you're using, so long as you end up with a negative 5 over 22, and it would work 100% of the time, it's certainly okay. Example 2. Again, looking to see that I see fractions. What am I going to have to multiply by in this problem to get rid of all my fractions? 6. 3 goes into 6 and 2 goes into 6. I'm just going to put parentheses out here in front, put a 6 out here. I'm going to skip that step that I said I normally would skip before. But you can see I'm going to take that 6 times each one of the 4 parts that were here. How many times does 3 go into 6? 2 times 5 is 10. 6 times 2 is 12. 6 times 4, 24. This 2 goes into the 6 3 times. This would be a negative 3x. Does everybody see I don't typically write down that step that's in between? It's certainly okay if you skip it. Everything is simplified, so I'm going to move things so I can get my variables together. X is larger on the left, so I'm going to get rid of the one that's on the right. And I'm going to add 3x to both sides. Getting x by itself, the next step would be to get rid of the 12. I'd have 13x is now equal to 12. And my last step would be to divide both sides by 13. Questions on this example? I want you to try this one, then, oh wait a minute, did I get it in there twice? I think I did. Yep. Well, I got 4 examples, I got it in there twice. I want you to try this one on your own. Eight. When I multiply by 8, 4 goes into 8 twice. This becomes 6a. When I multiply by 8 in the second term, the 8's would cancel out, leaving me 5. When I multiply by 8 here, 2 goes into 8 4 times. This would become 4a. When I multiply by 8 in the last term, 4 goes into 8 twice. This would be a negative 2. The nice thing about getting rid of the fractions is it certainly makes the problem a lot easier to work with. I get my variables together, subtract 4a from both sides. Leaves me 2a plus 5 equals a negative 2. Subtracting 5 from both sides, I have 2a equals a negative 7. And my last step would be to divide by 2. A equals a negative 7 over 2.
I
You did 3.5, which is fine. Again, I have a tendency to leave mine as improper fractions because if I had to do more work with this number, working with a -7/2 is easier mentally to work with than a -3.5. It just makes it easier because a lot of times your denominators will go away, mathematically speaking. They have a tendency to cancel out if you just leave them as improper fractions. But it's certainly okay to change it. I think one person actually wrote a -3.5. That's certainly okay as well. Questions? One more example then. This happens to be a unique problem because this problem is easier to do by leaving the fractions there if you notice it. Notice that these both have x's with it. They both have the same denominator. They are on different sides of the equal sign. And I'm just going to show you that it's really easy on this problem to leave the fractions there because I'm going to subtract 2/3 x from both sides. It would leave me 4. 8/3 take away 2/3 becomes what? 6/3. But what is 6/3 x? 2x. And what is 2x minus x? It's not to say that you couldn't do this one the other way, because you could. And we should still get what for an answer? X equals 4. If by chance you notice, though, that your two fractions have the same denominator, which I noticed right away by looking at this, and you see that the fractions are going to go away and it might be easier to work with it, there's certainly less steps in doing it this way than there is in doing it another way. Everybody see the difference between the two? Questions about how I did this one? Your assignment is a worksheet, same as yesterday.